Hey everyone, welcome to my channel. In this video, we are going to learn all about the CVZone library and how it can help us create projects fast and more efficiently. So I've been creating computer vision projects for more than 9 years, and I have seen that a lot of repetitions in different functions. So what I've done is I have created a library for this, which puts all these functions together, and it makes it easy for us to create new projects, and it makes it easy for us to integrate existing code into our new projects. So we have many different functionalities like plotting images, like detecting faces, detecting color, detecting contours, getting hand tracking, getting pose estimation, and we have lots of different functionalities where you can stack the images and you can overlay PNG images on your regular images, and you can download images from the internet directly using a single line of code. And there's a lot of functionalities. We are using our own fancy rectangles. We have box rectangles that have text as well. So all these functionality make our computer vision projects much richer and much more attractive, and you can create some games out of this as well, because you will be able to overlay crisp PNG images on different images, and you can create some really good graphics and some really good graphical interfaces as well. So I would highly recommend that you go through this complete course so that you understand how this CVZone platform works and how it can increase your efficiency. So this will be kind of a documentation for our CVZone library as well. So make sure you go through all of it. And if you find it useful, do subscribe and share it with someone who will find this useful. So let's go ahead and get started. Do you want to implement your computer vision ideas to solve real-world problems, or upgrade your resume by enhancing your computer vision skills? Then the computervision.zone is the perfect platform for you. CVZone is a one-stop computer vision platform with over 100,000 users, with courses sold in over 80 different countries. If you want to commercialize your computer vision ideas, then the Computer Vision Web Development course is the perfect course for you. Here you will learn the basics of web development and computer vision, as well as how to integrate them to solve real-world problems like customer engagement, car counter, face attendance, shirt size measurement, and a lot more. Advanced Drone Programming is another great course that focuses on the practical implementation. Here you will learn the basics of drone programming, as well as advanced concepts like face following, body following, gesture control, and a lot more. If developing mobile apps is your thing, then check out our Computer Vision Mobile Apps course. Here you will learn the basics and create several apps, including object detection, augmented reality, face detection, document scanner, and a lot more. The best part is that you will create a single app that will work both on iOS and Android. If you are passionate about integrating hardware with software, then check out our Computer Vision Arduino course. Here you will learn the basics along with amazing projects such as conveyor belt assembly, face tracking, lamp gesture control, face door lock, and a lot more. The Computer Vision Game Development is another great course where fun meets programming. Here you will learn to create games such as Fruit Ninja, Balloon Pop, Squid Game, Cookie Cutter, all using the latest computer vision techniques. Not only that, you will learn to compile your awesome game to an exe file to make it accessible to all. You can also learn to implement computer vision on embedded devices with our Computer Vision with Jetson Nano course. Here you will learn the basics of Jetson Nano and computer vision, along with creating exciting projects like lane following robot, eye tracking, object following, and a lot more. All these courses have a clear path from basics to advanced with maximum knowledge in a short amount of time. So check out the links in the description to get started with your computer vision journey today. So the first thing we will do now is to go ahead and install. So we will go to File and Settings, and here in our interpreter we are going to click on Python interpreter, and we will add CVZone. So when you add CVZone, it installs OpenCV and NumPy for you. And we will also need MediaPipe. MediaPipe will be used for hand tracking, pose estimation, and so on. And then we also need PySerial. PySerial will be used to communicate between Arduino and CVZone. And then we also need TensorFlow. TensorFlow will be used to detect the classification models. so we can install that too. So these are all the packages, and I have installed the latest ones. We have not installed any of the previous versions. And for CVZone, you can see it is currently at 1.6. So anything above 1.6 should be working fine. We have done some major cleanup for this. That's why I recommend 1.6 or above. So right now, everything is getting installed. So here we can see the background tasks running. And as you can see, they are almost done. So now that we have our installations done, what we need is a template for webcam. So we will be using our webcam for most of the testing part. So we will write import CV2, and then we will write cap cap equals CV2 dot video capture device, and I will be using device number 2. Most probably you will be using device number 0, because you will have your pre-built webcam, built-in webcam, or you have connected your first webcam. Right now I have multiple of these, that's why I'm using 2. Then we will write while true, and once that is done, we will write success, and our image equals cap.read, and then we will write cv2 dot imshow, and that will be our image, and we will write img and cv2 dot wait key and 1 millisecond. So that's giving us a delay of 1 millisecond. That is showing us our image, and that is reading from the webcam. So that's how simple running your webcam is. So let's go ahead and run that and see if it works. So there you have it. You can see the webcam is currently working, and I can move around, and that is good. So by default, we are getting 640 by 480 resolution, and we are fine with that. So let's go ahead and create our first file. We are going to name it corner rectangle. So corner rectangle is basically a rectangle that is a little bit fancier than the regular rectangle. So we will copy our webcam part and we will paste it here. Now, if you wanted to create a rectangle using OpenCV, we simply write cv2.rectangle, and we give in our image, and then we give in the position, the X and Y. So let's say 200, 200, and then we have to give in the X2, Y2. Let's say we will add 300 to this, so it will become 500, and 200 to that, and it will become 400. So once that is done, we have to give in the color. So let's say it's 255, 0 and 255, and then we have to give in the thickness, let's say 3. So if we write this down, what we can do is we can simply right click and run our rectangle, and this should give us a simple rectangle that we are used to of using in OpenCV. And there you go, that's your rectangle that we have. Now, the thing that I don't like about this rectangle is that you have to give in a lot of parameters just to make it run. So you could decide the color, and you can have the thickness by default, and all you have to give in is the image and the bounding box information, and that should be enough. And if you wanted to change, you could change as well. So that's why we have created, and we have created a little bit more fancier rectangle. So we can write here CVZone dot corner rectangle, and using this, all you have to give in is the image and then the bounding box. The bounding box is basically, let's say in our case, is 200 and 200, and then it's the width and the height. So it is 300 and 200. So we don't give the y2 and x2 and y2. Instead, we give the width and height. So this is pretty much it that is required. So if we comment this and if we run this, then you'll be able to see that we have a fancier rectangle that has some corners with borders, and all you had to do is you had to give in this line. So here you can see that we have a normal rectangle, and around it we have these corner edges. So you can actually customize this. Now this is by default, and if you wanted to customize, of course you can customize, and we have a lot of options. So if we click on the corner rectangle, And if we copy all of these, we will bring them here and we are going to paste. So image and bounding box we have already done, so we can remove those. And then we have the length. So this is the length of the corner. So the green part, this was the length of that. So you can increase and decrease. So let's say we make it 100 and you will see a significant change. There you go. So now the corner rectangle is a little bit different because we have given the length as quite high. And then you have the thickness of this. So basically you can change the thickness of this as well. So right now it's 5 and the thickness of the rectangle is 1. So you can have the ratio as you wish. So right now it's 5:1. You can have it as you wish. And then you also have the option to change the color for the rectangle, and you can also change the color for the corner. So it is up to you how you want to use this. In my opinion, this just makes it a little bit different, a little bit better, and it looks more appealing when you have it in the end product. So if you're detecting objects, if you're detecting humans, or anything you are detecting, if you use this rectangle, it looks a little fancier. That's pretty much it. And of course, you don't have to write these. These are optional parameters. So you can get started with just writing this as well. So this is our second part where we are going to learn about PutTextRect. So what exactly is PutTextRect? Let's have a look at how we can usually write text using OpenCV. So here you can see we have PutText. So if we are actually displaying, let's say, CVZone, and we are giving in the position and we are giving in the font, then we have the scale and we have the thickness, and in between we have the color. So there's a lot of parameters you have to give in by default to make it run. And then the problem is that if you run this, sometimes the background is not very good and you will not be able to read the text properly. So this is one of the issues that comes mostly in webcams. So here you can see we have CVZone written here, but again, it's not very clear and it doesn't look very good. So what you can do is you can put a rectangle, and above that rectangle, you can put the text. So for example, if I go to corner rectangle, and this is the basic idea of putting a rectangle, I will just copy this and I will paste it. And I will try to get to this position. So right now this is 100. So I will go a little bit before 100, let's say 80, and the height, let's say I will put 40. And then we have to give in the y values, the x2 and the y2. Now this is the problem here, that I don't know how big the text is going to be. So for me to manually do it, it's a very tedious process. So for example, if I write here, let's say 300, and here I'm going to write, let's say 200. So right now I'm just assuming and I'm going to run it, and then once I see the result, I'm going to use trial and error to actually find the best values. So right now I forgot to actually change that. Why is it starting so low? It is starting at 150. So this was starting at 40 and 80. Okay, let's just put this cv2.filled and we will run it again. So there you go. So this is our rectangle, and now what we have to do is we have to try to put it on this. So here, let's say, I'm not sure why it is going so big. Let's put this down a bit. So right now it's 50. Let's say we put 150. So as you can see, we have put the text and we have put the rectangle as well. And now it looks much better, but it's difficult for us to imagine or to guess where exactly is the bounding box. And if we just change one single letter or alphabet, then the sizing will completely change. So for that, what we have done is we have created a simple function called PutTextRect. And here you have to give in your image, and then all you have to do is you have to give in your text. So we will write CVZone again, and you have to give in the position. So these are the three parameters you have to give. So let's say I will give it 300, or let's say 200 and 300. So if we run this now, it is going to create the bounding box, the rectangle, and it will overlay the text on it, and it will automatically fix it in the middle. There you go. So now you can see you have CVZone written, and of course you can change the color of this. You can even add an offset on this. So let's go ahead and see how we can do that. So if we go to PutTextRect, we can copy all the parameters. By the way, if you're not familiar, you can press Control and you can click on the function, and that will take it to the directory. So that's how I am moving to the utilities. So here inside CVZone, we have a script called utilities, from which we are fetching these functions. So what we will do is we will paste it here, and image we have already given, text we have already given, and position we have already given. Then you have scale. You can just change the scale and it will automatically make it bigger, and it will fix and center everything. So for example, if I write scale as 8, so it will become much bigger, but it will stay within the constraint. So there you go. Not only did it increase the size, it increased the size of the rectangle as well. And of course you can change the thickness as well. Over here you can see thickness. Now we have different colors, so you can choose the colors as well. So the color of T is basically text. So here right now it's white. Then you have the color of the rectangle, so this is the background. Then you also can use different fonts. Whatever font OpenCV provides, you can use those. Then you have an offset. So you can say that I need a little bit of a gap between the text and the rectangle from each side. So for example, right now let's exaggerate it and put it 50. So you will be able to see how big of a difference does that make. So it will have an offset on each side, top, left, right, and bottom. So that's what we can see. So here you go. But you can see that CVZone is still in the center. So that's the best part. So you have offset on the sides, and that works fine. And then you can also have a border. So the border, you can give it a thickness, let's say 5. And then you can also decide the color of this border. Right now it's green. So let's run it and see what we get. So you are going to get a border around your rectangle. So there you go. So now you are getting a border around your CVZone box. And as you can see, it's much better and much simpler to work with. And of course, if you just wanted a border with the default parameters, then you don't have to give in all of these. You can pretty much remove all of this, even the scale, and you can remove the color as well. And then let's say you just give in the border 5, and that's it. So if you run this now, it should give you pretty much the same results, just without the offset, because we are removing the offset, so we will not have that. And there you go. So that's how good it looks. But I can see the offset is not very good, so I can increase the offset. So the offset by default is 10. Then we can put 20 to make it a little bit bigger, or you can put 15 as well to try out which one works best for you. So let's see how that works. So there you go. So now it looks much better than before, and definitely it's much clearer and easy to read. And imagine once you detect any object and you put this on top of that object, so it will look much better. And if you use the corner rectangle with it, then of course it will make things so much better in terms of appearance. So that's how you can use corner rectangle, and you can use the PutTextRect. So now we are going to learn how can we download an image using a URL and use it in OpenCV. So for example, here we have imported CV2, then we are importing CVZone, and then we are downloading using CVZone.download image from URL. That's it. So that's all you have to write, and this will be a normal image that you have downloaded. It will not have the transparency. So for example, if we just run that, let's comment everything else. if we just run this part and we run it, there you go. So this is our image normal. So this is a JPEG image that we are downloading, and it does not have any transparency. But if you did need transparency, what you can do is you can write the flag keep transparency equals true. In that case, you can have the transparency, and later on you can use it in your project, for example, to overlay on an image. So here, what I'm doing is I'm resizing this image because it's very small. So it's basically a logo. That's why it's very small. So I'm resizing it to make it a little bit bigger so that it's easier to move around. And then we will also display it. So this will be our transparent image. Not transparent image with transparency. So there you go. This is our original image, the normal image, and this is the image with transparency. So right now we have some text here as well, but because it's black, it's not showing us here. And one thing to note here is that right now you are getting this pixelated image. And if you overlay this on an image, a normal image, it will be pixelated, and you can use masking and all that to actually do this. But what we have is a function to actually overlay this image on our any regular image or webcam, and with some crisp image. So you will get very good results with that. So in the next part, let's go ahead and look at that. So now we are going to have a look at how we can overlay PNG images on our regular images. So we can get the transparency, and then we can overlay it on a webcam image or just a regular image, and so on. And this is very useful because you can create very simple games. You can add very simple graphics to make your OpenCV project very appealing in terms of visuals. So how can you do that? I will show you two different techniques. First is that we are getting the image from our URL, and then the second one is we have our image right in our directory, and then we are reading it here, and then we are using it. So let's look at how you can download and then use it. So we have the webcam template here. So as you can see, we have our image being displayed. We are getting the frame, and we are initializing our webcam. We are also getting the PNG image, and we are keeping the transparency. And once we download this, we are using the function CVZone.overlayPNG. Here we have to give in the image. We have to give in the image background. This is the image front, the one that we want to overlay, which is our PNG image, and then we have to give it in the position. So if you go to that function, these are the three parameters that you only have. So that's basically what we are doing. So if we run this now, it will download this logo from our GitHub page, and then it will display it on the position 200 and 200. There you go. And now the best part here is that it is doing this in real time, where there is no lag. And the best part is that the image is very crisp. As you can see here, the PNG is very crisp. Now, if you use masking and you overlay it, you might have tried it already, the image is not very crisp. And that's why we use this function, which actually uses a blending method using alpha channel to actually get this crisp image. So that's why it becomes so easy, and it not only gives us a crisp image, it also handles if you go out of the bounds of the image. For example, if we give a position that is not within our image, it will still display our image. So it will still overlay. It will overlay that part of the image that is supposed to be there. So for example, right now we have given the X value as negative, and you will see that it is drawing still that part whichever is in the image. And the same way you can do it after you can give it a value that is more than the image as well. So here you can see it is going to go beyond the image values, and we will see how that works. So there you go. So we have placed our values so that it actually exceeds, the image actually exceeds. And normally if you do this, it will give you an error and it will not display. It will say image out of bounds. But we have created the function so that it actually takes care of that error and it actually displays the part of the image that should be displayed. So you can have a simple game with this. For example, you have a ping pong game and you push with your hands, and then these these PNG image actually moves around and so on. So it can be very useful to actually have this. And then if you wanted to get this image from your directory, all you have to do is you have to write cv2.imread, and you have to give in your file name. So right now we have CVZone logo.png, and you have to write cv2.image. I forgot to write comma, that's why it's not giving. cv2.image unchanged, imread unchanged. So this is very important. So we can write here image png equals this, and now if we run it, it will give you the exact same results. But if you don't write this imread unchanged, it will not work, because then it loses the transparency or the alpha channel, and then we are not able to get the access. So there you go. It's the exact same thing. We are getting from our directory rather than getting it from our URL. So now we are going to go ahead and look at how we can rotate images, and you might think that it's very straightforward. You should already have a command to actually do that, but that's not true. And there are a lot of different things that actually go into the rotation of image than you might expect. So if you go to actually the rotating image, you can see that there is quite a bit of code that actually goes in rotating the image. And we also have an option to keep the size of the image while we are rotating, or to distort it. So let's go ahead and look at that. So here we are also showing another way of importing the CVZone functions. Now, if you are using only one function, or you are using very specific functions, you can add it like this as well. From CVZone.utilities import rotate image. So earlier what we were doing, we were simply writing import CVZone and that's it. And then we were writing CVZone.rotate image and so on. But if you wanted to, you could write CVZone.utilities and then you can import the rotate image. And that's the idea. And then we have our webcam like we normally have. We are reading the webcam feed, and then here we are displaying the image, and then we are waiting. So now we have two types of images, two types of rotations that we are doing. First is without keeping the size, and then the second one is with keeping the size. So let's remove the keeping size part, and we will look at how we can rotate. So you have to give in rotate image, and then you have to give in the image you want to rotate. Then you give in the angle at which you want to rotate. Then you have the scale if you want to increase or decrease the size. And then you give in the parameter keep size. So this by default is false. So this will not keep the size, it will actually change the size. So right now our image is 640 by 480. When we rotate it, the image size becomes different. So what do I mean by different? Let's go have a look. So let's actually look at the original image as well. So we'll write here image, and we will write here image. So let's go ahead and look at that. We need to run this instead of the previous module. So this is our original image, 640 by 480. Now look at the rotated image. So there you go. We have rotated it by 60 degrees, and you can see now the image size has changed. So it takes the size diagonally, and then it calculates all of that, and it moves the image. Now, if you wanted to keep the size, then you can use the keep size as true. So that will make it 640 by 480 again. So what it will do is it will crop the image, so you will not get the complete image. And there you go. So this right now is 640 by 480. This is the original image, 640 by 480. And then this is where you keep the size. So it is not going to change the aspect ratio, but what it will do, it will crop it. And you can see all of this is done in real time and it looks good. And of course you can do it for 90 degrees as well. So for example, if I write 90, it will change the angle to 90 degrees, and you can have a flipped image, a vertical image very easily. So that's how you can use this rotate image. So this is 60 degree, and this here you can see right now it's 90. So that's how simple it is to actually use the rotate image, and you can use this in many different projects, and it could be very helpful. And you can of course rotate the PNG image as well, the one that we actually got from our module, and then you can do it for that as well. So now we are going to have a look at one of my favorite functions, which is stack image. And this function, I believe, is the first one that I created that I really wanted in this functionality while I was creating OpenCV projects. So what exactly is stack image? So let's say I have my webcam image, and then I am converting it into grayscale, then I am converting it into blur, and then into canny, then I'm getting the edge detection and so on. So I'm doing a lot of processing on my image. Now what I want is I want to see my image on every single step. So what I can do is I can create these images. For example, here I have image gray. I reduce the size of it, I make it bigger, I convert it into canny image to get the edges, I convert it into HSV space, and I do all that. Now, how do I display it? To display it, what I have to do is I have to write, let's forget about this stack function. So these are the 3 lines you have to write for stack image, but let's say we are not writing that. Let's say we are doing it the normal way. So we will write CVIM show, and here we will write image, and then we will write simply image. So this will display us our main image, and then we will have our gray image. Let's say image gray, and we will write here image gray. Then we will copy this a few times, let's say, and then we have image small, then image big, and then we have image canny, and we have the last one as image HSV. So let's say we are displaying all of this. So I'm going to run this stack image function, and this will give us our webcam feed, and it will give us in all different windows. So let's wait for it to open up. So this is our main image. Then we have our image gray. Then we have image canny. We have HSV, then we also have the small one, which I'm not able to bring here. Then we have the big one, and so on. So if I were to use this method, I have all these different images all around. And every time I run it, I have to drag this windows and I have to move it around so that I can view, okay, which one was part 1, which one was part 2, oh, where is the big image, where is the small image? You know, it's not a very good process. I'm not looking at the iteration or the steps that are going through. So instead of doing this, what we can do is a more efficient way of doing this is stacking. So we will create a list of images that we want to display: image, image gray, image canny, image small, image big, image HSV, and then we will simply send this to our stack image function. That's it. Stack images, we will give in the list. Then here we basically have the columns. So this is basically columns, and this is basically the scale. Now columns is important, how many images you want in a single row. So 1, 2, and 3, and then it will go down. And then scale, we need the scale because if you put it as scale 1, then the image will become really big. So let's say you are using a 1080p video. So, and if you have like, let's say 6 images and you want to stack them together, then you need 6 monitors to actually view that. So that's not very reasonable. So what you can do is you can reduce the size to, let's say 0.2, 0.3, and it will squeeze down all of it, and then it will be visible. So for example, if I put this as 1, you will see that it will be a little bit difficult to view. And then once you have this stack image, All you have to do is you have to display only that stack image. That's it. So let's run that and see what happens. So there we have it. So as you can see right now, it's displaying all of this. And right now we have 3 columns, 1, 2, 3. And you can see it almost comes within our window. So if you wanted to change it, you can change it to, let's say, 0.5, and the window will be much smaller and it will be more manageable. There you go. So now it's much easier to see the complete process, and it is real time. As you can see, I can move around and it works very well. Now let's discuss 2 more things. The first thing is the columns. So what do I mean by columns? So if I put 2 columns, then I will have 3 rows because I have a total of 6 images. Now you might say, okay, what if I have 5 images? What if the last image I don't have? So will it give me an error? No, it will not give you an error. Actually, let's have a look at this first. So this is how you can have 2 columns. So now you have 2 columns instead of 3. You don't have to list down how many rows you want. It will automatically detect the rows or calculate the rows for you. So all you have to do is you have to give in 1 column, and that's it. So 1 parameter, which is columns. Then I was mentioning, what if you have 5 images? So what will happen then? What will happen is that it will automatically create a blank image and it would place it there. It will not do anything else. So it will display you a black image. There you go. So if you have an empty space, it will create another image and it will display it there, and that's it. It will not give you an error. Now the best part about this function is that it can handle different images. So what do I mean by different images? So normally, if you are using a stacking function, what happens is that if you try to stack a colored image with a gray image, the dimensions are different. So it will give you an error. But with our function, it will not give you an error. It can stack gray images. It can stack smaller images. So the dimension of this image, that's why it was pixelated, because the dimension of this image is 64 by 48. So it will resize that image and it will display it so that it looks like the other images. So it can handle bigger sizes as well. Again, it will reduce the size of that so that all of them are same. So which image size it will take? It will take the image size of the first image. So whatever is the first image size, which is this in our case, it will keep all of the rest the same. And of course, it can use binary images. It can handle HSV color spaces and other color spaces as well. It can handle all of those and it will not give you an error. Even if your sizes are way different, it will squeeze it, it will change the aspect ratio, and it will display all of those images in one single image. So I use this image stack a lot, and this is one of my favorite functions, and this actually runs with a webcam as well. So as you can see, it is quite fast, and you can add a lot of these as well. So if I do something crazy, let's see if that works. There you go. I will put, how many do we have? Let's copy all of these and we will paste. There you go. And we have double here, that's why it's giving an error. So here we have a lot of them. So what we can do is we can, let's say, have 20 in one row, and we can have the size of 0.1. So let's see how that works out. You will be amazed how well this function works. Actually, it displays the webcam in real time, and there you go. So if I move around, you can see all of these are working and it looks amazing. So let me reduce the columns, let's say 10 columns, and let's change this to 0.2. So let's see how that works. So there you go. So now you can see it works in real time and it looks quite good. So far what we have done is we have used some functions, and now what we will do is we will go ahead and use our first class. Now this class is FPS, and what this does is that this is very, very important for pretty much any project that has a webcam. So what you can do is you can display your FPS very, very easily and very accurately. Normally, if you are just using time to actually calculate the FPS, then it gives you some error. It is fluctuating a lot and it's not very reliable. So what you can do is you can average these values as well. So what we have done is we have created a class that actually handles all of that at the back end. So what you can do is you can simply write import CVZone, and then we already have our webcam. Here you can see we are reading the frame and we are displaying, and this part here is for the FPS. Let's just remove that. And here, let's just first discuss how exactly can you initiate it. So here you can write CVZone.fps. So we are creating an object out of this class, and the class name is FPS. The object name in this instance is FPS reader. And here we only have one parameter, which is average count. So basically it's asking us how many frames do you want to average to give you the end result. So for example, in this instance, it will take 30 frames and it will average those values, and then it will give you the frame rate. So it will be very sturdy. So what you can do is you can initialize your webcam here. Let's say I'm using webcam number 0. I have another webcam at 0. This webcam is special because it allows us 60 frames per second as well. And that's why we have written this line cap.set cap prop FPS as 30. So right now we will start with 30, and you will see it will be 30 frames per second, and then we will change it to 60, and then we will see if it actually changes to 60 or not. Then here in our function, in our main loop, we are looping through all the images, and then all we have to do is we have to call this function. So inside, all we have to do is we have to call our method update within our object FPS reader. So FPS reader.update, and we only have to give in our image. That's pretty much it. So if I remove all of this, and if I copy this part and paste it here, and I don't even have to give in the position, it will put it on the left corner by default. So that's how simple this is. So here, if I do this and if I run it, it will automatically calculate the frame rate, and it will display the frame rate on the top left corner. So there you go. As you can see, the FPS is around 30 frames per second, and that's how easily you can get it. Now, if you wanted to change, of course you can do that. You have these parameters to change, and I will share those shortly. But for now, let's change this frame rate to 60. So this camera actually supports 60 frames per second. That's why we will be able to get that. Otherwise, it will not work with normal cameras. So there you go. So right now we have around 60 frames per second, and you can see the value is quite stable. Now, what if we put the average count to 1? So pretty much we are not averaging anything. Then you will see that the value actually fluctuates a lot. So there you go. Sometimes it goes to 100, sometimes it goes to 40, and so on. So it's not very reliable. So the frame rate is not very reliable at this point. So that's why we need a good value like 30, and that will give you a good frame rate. Now, coming on to the options that we have several options here. First of all, the position. You can change the position at which you want to display. And this function is not only for displaying, of course, it is giving you back the FPS. So you can print out the FPS as well. You can simply write FPS. If you wanted to use the actual value, you can use that as well. So if we run that, it will give you a floating number, which will be your FPS. There you go. So these are the FPS values that we are getting. Again, coming back to our options, you can give it a different position. So right now it is giving a simple position. Then you have the background color. So it is displaying a rectangle, and on that rectangle it's displaying the FPS. So you can give in that color, and then you also have the text color, which is white by default. Then you have the scale, how big you want it, and then you have the thickness. So if you go to the update, you will see that we are actually using CVZone PutTextRect to actually display that bounding box and the text, because it actually centers everything for us. So it becomes very easy for us to use it in our other functions and other modules as well. So this is how you can integrate FPS in any of your projects, and it is very useful in webcam projects where you want to see the response, and especially in object detection part where you want to see how much lag are you getting when you are running the inference. So this is very useful. So now we are going to go ahead and look at finding contours. Now this method is already available in OpenCV, but what happens is that you need a lot of different lines of code to actually run it. So there's a lot of predetermined variables, and you have to give in a lot of parameters to actually run it. And then after running it, most of the times you are getting the contours, and then you are getting the bounding box information, and to get that you have to write some more lines of code, and then to filter it out based on area or based on how many corner points it has, you have to write more lines of code. So what we have done is that we have seen what exactly do we need in different projects, and we have put it all together in one function, and we call it the same find contours, and you can use it within the CVZone library. And what it will do is it will sort different objects for you. It will allow you to filter corner points, and it will also allow you to have all the functionality of your original find contours function as well. So let's go ahead and see how we can do this, because this will increase your productivity for finding objects, especially when you are subtracting with the background image very quickly, and it will make your life much easier. So how can you do this? You will import CVZone, and you also need NumPy for this. So we are importing it as NP. Now we need an image. So this image we are getting from our URL directly from GitHub. Now if you wanted to, you can add it to your repository as well. So this image is of shapes. Then we are converting this image into Canny, and then we are giving a little bit of dilation. We are making the image a little bit thick, and then once that is done, this is basically pre-processing of the image. Once pre-processing is done, then we will send it to find contours. So we have two types. The first type is where we are not filtering anything, and then the second type where we are filtering. So let's remove the filtering part, and let's start with non-filtering. So again, all of these red ones are optional. You don't have to give these. So basically what you can do is you can simply write that image contours and contour found equals CVZone find contours, and you give in the original image and you give in the processed image. That's it. And you will be able to get your contours. So if we remove this and if we run it, there you go. So by default, it is getting all the contours, it is getting all the bounding boxes, it is getting how many corner points each one of these has. And not only that, it is also displaying us all this information. So here you have 8 corner points, here you have 3, here you have 4, here you have 4, and so on. So now if you wanted to filter, of course you can do that. Now filter based on area, for example, this is the minimum area. You also have the option of maximum area. So let's say the maximum area is 100,000. So it should not be above this, and then it should not be below this. So then sorting, if you sort it, then you will get the biggest contour in the 0 position, then the second biggest in position 1, then so on. And then filtration, I will explain later on. Then do you want to draw on the original image? Yes. If you don't want to draw, you can remove that. Then the color of which you want to draw, and then you have the color of the text as well. The text that you saw, the number of corner points that we are getting. Then you have the retrieval type, which is basically part of the original find contours function, and the approximation type. And if you wanted to, you could change these as well. So that's the basic idea of how you can use this find contours function and what exactly is in the contour found. So let's print that, print contour found, and we are going to run it. So currently it's taking too long and it is giving us an error because it tried to get this image, but it was not able to. So what we can do is we can simply get it from our GitHub page and we can bring it in our folder. So here, shapes.png, and we can write it like this, or we can write it like this. So you can have it, for example, cv2.imread, and you give in the file name, which is shapes.png, and that's it. So if we run this now, we should be able to get it. There you go. So this is basically your image, and this is your found contour found. So what exactly is this? What are we getting? So inside this, we will have a contour. So this will have all the points that were detected. Then we have the area of this contour. Then we have the bounding box of this contour. We have the center point of this. And then we have the actual contour. Now this is the next one. So this is basically the main idea. So it actually gets all of this, and every now and then you will see this is basically your area, bounding box, center, and contour. So each of the contours, each of the shapes has area, bounding box, center points, and all of this information. So that's what we are getting from confound. And as I mentioned before, you can also filter it based on the number of corner points. So for example, if I wanted to filter it, this is the most bare minimum code to run this. This is with your different parameters, and this is using filtering. Now, if you put filter as none, it will not filter anything. But if you want specific corner points, you can add here. For example, if I wanted only triangles, I can put 3 here. If I only wanted rectangles, I can put 4 here. If I wanted triangles and rectangles, I can put 3 and 4. And you can add more as well if you wanted to. So that's how simple it is. And let's open this up, the filtered image, so we can see what exactly is the difference, whether it's filtering or not. So this is the original image with everything without any filtration, and this is the image with filtration. So here you can see you are getting only rectangles and triangles. You are not getting the circles. So it is filtering 3 and 4. Now if I wanted to filter only 4, I can do this and I can run it again, and this time around I will not even get the triangles. I will only get the rectangles. So that's how simple it is. That's how easy it is to get this up and running. So you don't have to write all this lengthy code. Actually, let me show you. If you go to find contours, so you have to write all of this every time to actually sort it and run it. So what you can do is you can simply call this single line function, and it will give you all the information. So now we will go ahead and look at our color module. And the first thing you have to do is you have to import CVZone. And from CVZone, we are importing the color finder. So this is basically a class, and you have to create an object, and that object is my color finder. And inside that, we have only one option, and that is, do you need track bars? Now, if you request for track bars, it's basically debugging mode. And if you don't request for track bars, then it means that you are not debugging. So here we have the code for our webcam, and then we have the webcam reading parts, and then we have our image stack. So we are using image stack because we have multiple images, and you will be able to see how we actually use this in our different projects to make our life easier. So if, for example, if you don't know the color and you want to detect a color, what you can do is you can get its HSV colors. So using this HSV colors, you can find that object, but you don't know the HSV colors of your object. So how can you do that? What you will do is you will write track bar is true, and in your code, you are going to write my color finder dot update. You will give in your image and you will give in an HSV values. Now these HSV values can be 0 for now. It can be nothing. When you are using trackbar, it will not care about these values here, but you still have to give it, but it will not care about these values. So it will return you the actual color image and it will return you the mask image. So using these images, you can actually display them, or you can use it further to get the contours and so on. And I will show you later on how easy it is to find the contours from this. And this will create a complete project within a few seconds. And I will show you that later on. But for now, we are going to run it with the track bars. And let's say we are going to detect this object. So the track bars will open up first, and then the webcam will take a while to load up. And once it starts, it will give us 3 images. There you go. So here we have our 3 images, and here we have our track bar. So this is the colored image and this is the mask. So what we need to do is we need to move this around so that we only have that region that we want to detect. There you go. All you need is a little bit of faith that it will work at the end, and that's it. So this basically, this is how we are getting this object, and you can see how simply did we get this. And the best part is that while you're running it, it is displaying the output. So all you have to do is you have to copy this and you go here and you paste it. That's it. And now you turn the track bar off, and that's it. Now it will give you the actual result image each time. So you will not get the track bar this time. All you will get is the image orange and the mask, and also it will display us the original image. So there you go. So if I bring in the object, there you go, you can see it's detecting the orange color properly. So that's the basic idea of how you can use color module. But you might say, okay, we don't have the location of this colored object. How can we do that? So you can do that by very simply using our color and contours. So let's create that project very quickly. We will copy the color parts and we will write here color contour example. Okay, and what we will do is we will open up, we will close our color module, and then we will open up our find contour. And here what we need is basically our image shape we already have. So basically we have the mask, we already have the mask. What we need to do is we need to send it to our find contours. So what we can do is we can copy our find contours and we can paste it here, and then after, all we need to do is we need to give in the original image. So we will write here image, and then we will give in our mask. That's it. And then once we get the image contour, we will put it with our list and we will make this 2 so that it's a little bit easier to view. So we have 2 in one column. So there we have it. So if I bring it in, and there you go. So right now it's detecting the object, but because there are 2 different objects, it's detecting as 2 different. That's why we are getting 2. But you can see how well it performs and how quickly did it perform, that we are actually able to detect color and we are able to detect the object as well. You can see if I do it from the back side, you can see we are getting it as one single object. So that's how simple and that's how powerful this library is, that you can, with a few lines of code, with just these 2 lines of code and then image stacking, we are actually getting our colored object, and we are getting its location as well, the X and Y. So if you just wanted the location, what you can do is you can go to confound, you can loop through all the contours, and then once you have, let's say, confound at 0, then you can say, let's say I need the center point of it. So that's how simple it is to get these values. So now we are going to go ahead and look at our classification module, which basically uses TensorFlow with a teachable machine. So if you go to teachable machine with google.com, you can select and create your projects. Let's say we create a standard image project, and using your webcam, let's say I'm creating, let's switch to the other webcam. There you go. And let's say I'm creating a classifier. So it will classify whether I'm wearing a mask or not. So I can hold and I can move around. And there you go. Oh, I look like I'm a crazy person. So let's say I get these images, and then for class 2, I get the images with the mask. Like that. There you go. I move around, move back and forth. I'm lazy and so on. So that's how I collect the data, and then I can train the model. So I'm just showing you an example. Of course, you have to add more variable data as well, more dynamic data that is changing. So here we can test it out. So this is class 1 without mask. This is with mask, without, with, and we can change the class name. This is without mask, and this one, or let's say no mask, and let's say this one is mask. So let's train it again. It is very quick, that's why I'm training it again. Otherwise, if it took time, we would not do that. So right now it's showing no mask. Flip, come on. Why is it not flipping? Flip. I'm not sure why the camera is not changing. Let's go to Nexigo. Okay, anyways, so let's say we have tested it here and it works. What do you do next? You export, you go to TensorFlow, and here you select Keras and you download my model. So once you download it, so here you can see the file has been downloaded, and then you have label.txt and Keras model.h5. So these are the two files that we will need. So we can close this, and we can close this as well. Make sure you close this, or at least disable the webcam, because later on we are going to go ahead and use it in our project. So if it's running on the browser, it will not run here. So that's obvious. So let's go ahead and look at how this works. What you do is you import CVZone classification module, you import the classifier, and then we are initiating our webcam, and then we are giving in the path for our model. So here we are importing our Keras model.h5 and the labels.txt, and we are giving in the path. So right now my path, it is available at this folder. So after this folder, we have this file and this file. So once we create our classifier, all we have to do is you have to write your name of your object, mask classifier dot get prediction, and you give in the image, and then it will output you the actual prediction values, so the probability of each of these classes. And if you wanted to, it will also display the results. So how does it display? So it has the option for draw true. So by default, the draw is true, and it will draw a bounding box, and it will display us mask or no mask. So let's go ahead and run that and see if it works. So now it is loaded, and if we open this up, so it says no mask. If I go close, it says no mask. If I put it on, it says mask. No mask, no mask, and mask. No mask and mask. So that's how simple it is to run this classifier. And what happens is that it is actually giving us two values. So the probability of it being no mask and the probability of it being a mask. So right now, of course, this one is mask because it is the second one. So where are we getting this from? We are getting it from prediction, and it is also giving us the index of the highest one. So right now the index is 1. So this is 0 and this is 1. So it is giving us the index of 1. This is verbose by default. It is giving us the output. So we are not displaying this. We are actually displaying this part. So that's how you can create your classifier very easily and run it using CVZone. One more thing to remember is that if you are using the classification module, it requires TensorFlow. So make sure you have installed TensorFlow by going to File Settings. We have done this in the beginning of the. So here you can write TensorFlow and you simply install it. We have installed the latest version and it does not yield any errors. So now we are going to go ahead and look at face detection module, which is basically a wrapper for the media pipe library. So if you go to File Settings, make sure you have installed media pipe, and we have installed the latest version and it works fine. So make sure you do that. And MediaPipe, they change their parameters every now and then. So we had some issues with those, and some of it was our mistake. We should have updated it more quickly. And sometimes MediaPipe, they just change many things all at once. So it can be a little bit problematic. So we have fixed the code so that is a bit of a standard and it is not using different methods in different areas. So what we can do here is for face detection module, what you have to do is you have to import the face detector. Again, it is a class. So we have the face detector class and we are going to define that class. And within this, you have the option of selecting the minimum detection threshold and the model selection. The model selection is basically 0 for short range. Within 2 meters, if your face is present within 2 meters, use 0. If your face is for long range, use 1, let's say within 5 meters. So that's the basic idea. And this is the confidence, the percentage at which it should detect a face. So if it is 50% sure that it's a face, it will detect it. Otherwise, it will not detect it. Then all you have to do is you have to write detector. This is our detector dot find faces, and you give in the image on which you want to find the face, and you write draw equals false or draw equals true. So depending on if you want it to draw, you will write it here. And what we are doing here is we are drawing ourselves. That's why we have written draw equals false. And the reason I'm showing you how to draw it is so that you know how to extract the information and use it. So what we are doing is we are checking if there was any face detected. If there was any face detected, then we will loop through all the bounding boxes. So we will go through each bounding box, and within the bounding box, we have the information of ID, bounding box, score, and the center. So how can we get it? For example, we can write bounding box and then we can write center, and it will give us the center position. It's basically a dictionary. So you are giving in the key and it returns you the value. Similarly, we are getting the bounding box, X, Y, width, and height. And then we are also getting the score, and we are converting it into a nice percentage value rather than decimal places. And then we are drawing the data. So we are using a circle to draw the center point. Then we are using the PutTextRect to actually display the percentage, and we are using the corner rectangle to display the corner or display the rectangle around it. So it will be a little bit fancier to work that way. So let's go ahead and run this. So there we have it. So as you can see, we have our rectangle, and we also have our fancy rectangle around this. We have our text as well, and we have the face detection working. We have the center dot as well, and all of this is working well. And now one more thing we have is, where is it? What we can do is here in the PutTextRect, we can add a border, and we can, let's say, border of 5. So it will create that border around it, and I believe it will be green in color. So there you go. So you have that, and now you can see it created a border around it, and that's how easy and simple this is. If I put it on, it says mask, no mask, no mask, and mask. No mask right now. So you can of course push it up a little bit, and it will make it look a little more nicer. There you go. So that's the basic idea of how you can detect face and how you can draw things around it. So now we are going to go ahead and look at our face mesh module, which is basically, again, you can import it as CVZone.faceMesh module, and you will import the face mesh detector. So again, we are creating our detector. For that, we have some modes. So we have a static mode, we have faces, number of maximum faces, minimum detection confidence, and minimum tracking confidence. So all of this is explained here. So if static mode, it will only detect once and then it will track. If it is false, it will keep detecting. Then you have maximum number of faces. It's obvious how many faces maximum you want. A minimum threshold that we have discussed in our face detection as well. And minimum tracking is basically after detection, when you start tracking, what should be the tracking threshold. So we are basically creating our detector, and when we use our detector, we simply say detector.find face mesh, and here we are giving the value true because we have 400 plus points and it's a little bit difficult to draw all of them. So we are using the built-in functionality of MediaPipe to actually draw it. And once it is drawn, I will show you how to get each point and how we can find the distance between each point. So for example, we can create a blink counter using that. So let's go ahead and run this first, see if everything is fine, and then I will show you the rest of the code. So if we open this up, there you go, you can see my face, the mesh has been detected, and we have all those different points being detected as well. Now, what if we wanted to get a single point and we wanted to find distance, let's say between 2 points? So what we will do is we will say that if there are any faces that are detected, then we will go through each face for face in faces. Then within that face, we will get the point number. So if you print out the face, this face, it will give you 400 plus points. So each point will have an X and Y value. So what we can do is we can write face at 159. Face at 23. This will give you the specific points which one you require. So for example, for our left eye, the face, we need 159 point number, and for the left eye down point, which is basically this here, this is the bottom point and this is the top point. So we need those to find the blink. So we will see what is the distance between these 2 points so that we can detect the blink. So in order to detect it, it's very simple. You will simply write detector.find distance, and here you will give in the points. Now, this is the part where most of the confusion comes in. Pretty much in face detection, in hand tracking, in body pose and all that. Whenever you are finding distance or you're calculating the hands, this is where the problem comes in. This was not very standard at the back end. Which was our fault, and we actually fixed it now, and all of these are pretty much working with the same principle. So here you don't give the ID number. For example, you don't write here 159. What you send in is the X and Y position. So if I print out my left eye up point, and if I remove the print from here, and if we run this now, no, this is for face mesh. Yeah, it's for face mesh. If we run this now, you will see that we actually get the X and Y value. So here we are getting the X and Y value. So this is what you have to input to this function. So X and Y value, X and Y value. So nothing else, not numbers, not 3 values, not 5 values, 2 values, X and Y. So X and Y here and X and Y here. So these are the 2 values you have to input, and then it will give you the vertical distance or whatever distance you have chosen. And then it will also give you the information. What is the information? For example, if I were detecting my eye points, let's say top and bottom, it will give you the top point of this, bottom point of this, and it will also give you the center point of this line. So that's quite useful. But we are not going to use the info for now. What we will do is we will print out our left eye. So we will see when we are blinking, does it actually change or not? So let's run that and see if it works. So there we have it. If I move closer and if I blink, you will see the values, they change. So it goes to 12. Earlier it was 20 something. And now if I blink again, you will see the values, they go to 11, 12, 10. So half of it reduces. So it goes to almost half the value. So that's why we can say our distance is working and we are getting the values properly. So this is how you can use face mesh module to actually find and detect your blink and your face as well. So now we are going to go ahead and look at our selfie segmentation module. Here, basically what we do is we import our selfie segmentation class, and using this class, we are creating our model. So here we only have one model and one parameter, which is model. 0 is for journal, 1 is for landscape, which is a little bit faster. So based on your requirement, you can change it here. So what you can do is once you have your segmenter, what you can write is segmenter dot remove background, and you have to give in your image, and then you can give in either an image or you can give in a color. So right now we are giving a color, so it will display a color at the back end. If you had an image, you can display that too. But the image has to be the same size as the original image because it has to match. So that's the idea. And then you have the cut threshold, which basically allows you to increase or decrease the value at which it cuts your body. So let's go ahead and run this. Again, we are using the stacking function to display the image and the image output. So this is simply returning us the output. And let's run that. The rest of the code is simply for our webcam, which we have seen earlier as well. It's pretty straightforward and similar to what we have done earlier. So as you can see, it is segmenting my body very nicely, and it is a good selfie segmentation. So if I move around and if I remove the chair, it will be much better. And as you can see, it works really well. So of course you can play around with the cutoff, the threshold here, and you can add an image here as well. You can simply say import an image, read an image, and you can add an image here as well. But as I mentioned earlier, it has to be of the same size. So now we are going to go ahead and look at our hand tracking module, which is one of the most used modules out there. So what we will do is, first of all, we are going to import our hand detector. This is our class, which is present in our hand tracking module. So we will import that, and then we are going to create our hand detector. So we will simply write detector equals hand detector. So here we have all these parameters that allow us to make changes. So let's go through these. It's pretty much the same. We have static mode where it will only detect and not track. And then we have maximum number of hands, model complexity, detection confidence, and minimum tracking confidence. You can learn about these by clicking on the control button and then click on the mouse button, and it will show you the explanation here as well. Okay, so once we have that, what we can do is we can simply go to find hands. And here we have two options. We can draw our hand, and we can also flip. So sometimes left is right, right is left. So in that case, you can simply flip, and that will help you out. And then what it returns is that it returns us an image, and it returns us all the hands with all the information of the hands. So once we have that, then we can go ahead and use our other functionalities. But before we do that, I'm going to comment all of this. Before we look at that, we are going to go ahead and run this just to make sure that we are heading in the right direction. So there we have it, and there you go. This is actually my right hand. This is my left hand, and you can see it is detecting quite fast, and it is good. And that's the main idea. So once that is done, what we will do is we will check if we have any hands. So that's the first thing we will do. If we have any hands, we will take the first hand, and then we will get its information. We will get its point. Landmark list are the points. So point 1, point 2, point 3, and so on. So these points, they basically contain X and Y values. And yes, one more thing. They don't contain X and Y. They contain X, Y, and Z. So this is the confusion that most of you have. X, Y, and Z. So it's not only X and Y. It contains X, Y, and Z. That's why when you send it to find distance or when you send it to finger up, sometimes it gives you an error because you are not sending 2 values, you're sending 3 values. And the system gets confused. Which values do I use? So When you get the landmark, it will give you X and Y and Z values of 21 landmarks. And based on that, you can actually make your calculations. And then you also have the bounding box information, you have the center point, and you have the hand type. Hand type is basically whether it's left or right. So that's the idea. And then now we have created a function which is fingers up. Now for fingers up, all you have to do is you have to give in the complete hand. You don't give in X, Y, X, Z values, no, because we are not talking about any particular points. We are talking about the complete hand, and within those hand, we need to find out which fingers are up and which are down. So you have to give in the complete hand. You cannot give in hands because it is a list. It is a list of hands. It should be a single hand. Okay, so we are giving hand number 1. And using this, it will give us basically how many fingers are up. So it will print us how many fingers are up. And what we can do is we can open this print as well. I will share the reason later on, but let's see how it works now. So there you go. So if I bring in my hand, it's saying I have 5 fingers. If I close, it says 0. If I put 1, 2, 3, 4, 5. There you go. It works fine. If I bring in my other hand as well, and now if I bring in the other one, it doesn't actually display me the count of the other hand. It is displaying us this distance, and I will share how it's doing that. So to find the distance, it's the same thing like we did earlier. So in our which module? We used it in face mesh. In face mesh, we got the X and Y values and we sent it to our find distance. So the same way, as I mentioned earlier, this landmark list will give you 21 landmarks. So first of all, you have to tell which point are you referring to. So point number 8 is the tip of the index finger. So we are referring to this. Now inside this, we have 3 values, X, Y, and Z. So what we need are the first 2 values only. This is what this means. So include 0, include 1, and then don't include 2. This is what it means. It's a little bit confusing, but that's what it means. So this will give us the X and Y value of point number 8. And then this will give us the X and Y value of point number 12, which is the tip of our middle finger. Once we have these, then we are going to send it. Now, if you wanted to make it a little bit easier, you can write here tip of index finger equals this, and then tip of middle finger equals this. And before we actually calculate and do all that, let's just print it, because I want you to be very sure of what you are sending before you actually send it. So let's run that. So this is the tip of the middle finger. It should contain only 2 values, X and Y. So when we bring in our hand, there you go. We are getting the X and Y value. And if I change it, if I move it around, you will see the value actually changes. So now what we can do is we can simply send it to find distance, and we can also open this up. So here we have to give in the tip of the index finger and the tip of the middle finger, and we can run it, and we can remove this. Let's rerun it. So there you go. It's giving us the drawing as well, and it is giving us the distance of it. Now, where is the distance? The distance is in the length. So we can print that distance. So let's print the length. And what we can do is we can also make changes to the color of this and the scale of this. Let's say I will put it as 5. So it will become smaller. So the drawing will become smaller. So let's run that. And by the way, you also have the option, if you don't give in the image, it will not draw. So if you don't input any image, it is not going to draw, and it will not give you an error. So there you go. You have the length here, 36. Here you can see the drawing is now smaller. We have a smaller drawing, and let's look at the distance. So here the distance is around 100, and here it's around 20. Here it's around 130. Here it's around 20. Here it's around 80. So as you can see, we are able to find the distance properly. So that's how you can find the distance of the fingers. And then what if we have two hands? So we will check, once we go inside and we check there are hands, we will check if the length of this hands is 2. So if you have two hands, then only we will perform this. Otherwise, it will give an error, because if it's only one hand, it will be unable to process. So once we get the value of this hand, then we can simply do hand 2 like we did here. Hand 1 is hands at 0. Here hand 2 will be hands at 1. And then we will get the landmark list, bounding box, center, and the type and all that. And then what we can do is we can find the fingers up of this hand as well by writing hand 2, and then we are printing it. So if I run it now it will give me the tip of both of them. The fingers. So if I put them down 0, 0, 0, I have one of them up, 2, 3. Here, let's say I put 3 as well, or here I put 5. So there you go. It is giving me the values. And as you can see, we also have a distance within these two. So you can find the distance of between your hand, a finger between your hand, and you can also find the distance between two hands. So 2 fingers. So how can you do that? You can get the index finger of our first hand, which we already have, which is basically tip of index finger here. We can put that here. And then we can write tip of index finger 2 equals this. So now what it does is it gets the index finger of one hand and the index finger of the second hand, and then it finds the distance between those two as well. So it will give you the length of that, and the info basically is the points, the 2 points and the middle point as well, of the center point of that line. So if you wanted that, you can get that information. So if you go to find distance, and if you go to info, it's basically x1, y1, x2, y2, and cx and cy is the main idea, that you get the center point as well. So that's the main idea of how you can do this. And here you can see we have changed the color of this to blue. Earlier it was purple, and now we changed it to blue, and the scale is 10, so it's bigger. So again, you can have some sort of flexibility here as well. You can keep changing. And here we are printing an empty space so that it goes into a new line, because here we are stopping the new lines because we want the answer of H1 fingers and H2 fingers in the same line. That's why we are adding this, that the end is a space, and here we are putting a new line so that it is easier to read. So these were our functions for our methods for our hand tracking module, and as you can see, they are very simple and you can use them in your own projects very easily. So now we are going to go ahead and look at our pose module, and the first thing we will do is we will import it. So here we will write CVZone pose module import pose detector, and we are creating our pose detector with our flags. So here are all the options: static mode, complexity, smooth landmarks, enable segmentation, smooth segmentation, detection, tracking, and so on. So you can read all about this by pressing Control and click on pose detector, and you will find them over here. Then if we go down, basically what we are doing is we are creating this object detector, and once we have that, we simply write find pose. What this will do is it will find the pose for us, but in order to extract the x and y values, the points and all that, we need another function called find position. So once we run this, we have to run find position. So you cannot run it before that. You have to run first find pose, and then you can run find position. Inside this, you have the function of draw. So you can draw, and basically we are drawing the bounding box. So now, do you want to include bounding box in the hand as well or not? So the hands, for example, if you do this, the bounding box will become bigger. If you do this, the bounding box will become smaller. So do you want to do that? If yes, put it as true. Otherwise, if you don't want that functionality, put this as false. So that's the basic idea. What it gives us is the landmark list. So it has a list of all these different landmarks which we can use to find these points, X and Y values. And we also have the bounding box information, which includes the center point and the bounding box area of the body. Now, remember that we can only detect one body using this module. So that's what we will be doing. So once we have our LM list, once there is a body detected, we are going to go ahead and find its center. And then we are going to display this dot on our body. So this is just to show that how you can extract the information and display it. But now comes the fun part. We have 3 different methods within this pose module that will help you create projects really, really fast. But before we do that, let's just run this part here. We will ignore this and see if everything is working fine, and then we'll move on to our next part. Oh, we are getting an error, is close, angle 50 is not defined because we are printing it here. We need to remove that, and let's run it again. And there you go. So this is basically our pose module, and as you can see, it is detecting very fine and it works. It is getting the bounding box as well. And if I move my hand, the bounding box does not increase, it stays the same. So if I put that as true, then it will increase and decrease based on the bounding box as well. Okay, so now let's look at the different methods that we have that make this very useful for us in different projects. So the first one is find distance. Like we have done earlier, it's pretty much the same code. All you have to do is you have to give in the landmarks. So let's say I'm giving the landmark for my shoulder and my wrist. So it is 11 and 15. And again, we have to give in the X and Y value, not the X, Y, and Z. We have to give the X and Y value. Don't give in 3 values. So all you have to do is you have to give this, and the remaining is up to you. If you add an image, it will draw on the image. If you give these parameters, it will draw the color and the scale based on this. So let's run this, and now we will have a blue line between my shoulder and my wrist. So if I move my hand, you can see there is a line between my wrist and my shoulder. And as you can see, we are able to get this length as well. So if we print it out, definitely we will be getting the print as well. So that's the basic functionality of find distance, how you can use this. Now let's move on to the second part. So this here is finding the angle. So the angle is in between 3 different points. So for example, I will find the angle between my shoulder, my elbow, and my wrist. So what is the angle between this? So for example, if I'm doing reps, then it will be useful for me to find this. Again, you can do this for your legs. You can do it for other parts of your body to see the angle of the movement. Now, what you will do is you will give in your points, and again, you will only take X and Y values. Don't take X, Y, and Z. This is the problem that most of you face within the versions of the library. So now we have kept it standard. It will be X and Y, and that is what you have to give in. And then the rest of it is same. You have to give in the image, color, and scale. This one will be red in color. So let's run that and see if it works. And we also have some circles around it that we draw by default because it makes it a little bit nicer. That's why we have added those. Okay, so have a look at this. So you are getting this triangle. And as you can see, it is also displaying this value to us. So it's 89, 90, and there you go. So there you go. It is quite good. So right now it's around 180, and right now it's around 40, 30, something like that, because I cannot go below that. So that's the basic idea. And then we also have another function which is very useful. This method is within our detector class that it checks the angle. So for example, if I'm moving and I want to check if I have reached, for example, the angle of 50. So whether I have reached it or not. So reaching the exact 50 angle is not realistic. You might reach it, you might not reach it. So what you have to give it, you have to give an offset. So for example, you will say, okay, 50 means from 40 to 60. Okay, if my value is between 40 to 60, so I'm giving the offset of 10. So 50 plus 10 and 50 minus 10. So that is the offset. So what you do is you simply give your angle, the current angle you are getting from here, and you are checking this angle whether it is close to 50 or not. So is close angle 50? Is it? So the target angle is 50 and the offset is 10. If you think the 10 offset is too much, you can write 5. So then it will become 55 and 45. So if the value is in between that, it will return a true. Otherwise, it will return a false. So we can print this. So is closing angle 50, whether it's true or false. So let's go ahead and check that out. So there you go. Right now it's false because my angle is around 100. So if I go close to 50, you can see it becomes true. If I move forward, it becomes false. If I go down, it becomes false as well. If I reached around 50, you can see it becomes true here. So this is false, it becomes true, and then it becomes false again. So that is the threshold that we are using. So it makes it very easy for us to use this in different projects and see whether we are getting our desired results or not. So this is basically our pose module, and it has these 3 different methods that allow us to get the results very quickly and create our projects very quickly. So now we are going to have a look at our serial module, which contains a serial object. Now what this does is it allows us to communicate with Arduino very easily. So what I found is that communication between Python and Arduino was a little bit difficult. So I created a CVZone package for Arduino, and then I created a CVZone module, serial module for our Python package. So this is that module, and this is that class serial object. So all you have to do is you have to write Arduino, and then you initiate your serial object. Now inside, if you are using original Arduino, you don't have to give in the port number. It will find that Arduino and it will connect to that automatically. So for example, I'm using Arduino Uno right now, and this is the original one, so it will connect automatically. So then you have the baud rate. So you can define this. By default, it's 9600. Then you have the number of digits you are sending. For example, if I was sending 0 to 100, so then it means I'm sending 3 digits. If I'm sending, let's say 0 to 10, then I'm sending 2 digits. So right now we are only sending 0 or 1 because we want to turn on or turn off the LED light. So that's why we are writing 1. And then we have max tries. So sometimes what happens is that Arduino does not communicate properly, so it doesn't link up properly. So what you can do is you can have multiple tries before it exits, rather than pressing play again and again. So we have this parameter where it will try 5 times before it will say I'm not able to connect. Okay, so here it's so simple, so simple. All you have to do is you have to write arduino.getData, and it will get the data, whatever you are getting. And then to send it, you have to write arduino.sendData, and you will give in whatever you want to send. So here we are sending 1, here we are sending 0. If you wanted to send multiple numbers, you can simply write here, for example, another number here, and so on. But for now, we only need 1. So that's what we are doing. And what we are doing here is we have created a counter. Now, we have created a counter because we don't want to add delays, because it's communicating between 2 different things. We don't want to add delays. Time.sleep, that's not a good idea. So that's why we are adding a counter. So it counts till 100. And in that 100, it is sending a value of 1. And if it is between 100 and 200, it sends the value of 0. And then it resets the counter. So that's the basic idea. Now, this is all in the Python part. Then we have the Arduino code, and I added it here so that it's easier to copy and paste. So we can just remove the comments and copy it, and we will go into our Arduino. Now here you have to make sure that you install the Arduino library for Arduino, which is here. And how you can do is you can go to tools and you can go to include library, add zip library, and the name of this library is CVZone. So here you can see it's CVZone, and I've already added that. And this is also available for free. We don't charge for this. You can download it from our website, and you will have the access to all of this code as well. And of course, you just have to register on our website for free, and you can get everything. So let's have a look at this code. So here we have to write serial data, and we are writing the number of values we are receiving. So we are receiving only one value and the digits per value. So the digits per value right now is 1, because either it's 0 or 1. If we were receiving, for example, 10, 11, 12, then the digits will be 2. And if we were receiving 3 digits, then we will write 3 if it was between 0 and 999, and so on. So right now we are receiving one value, and that value has only one digit. So that's the basic idea. Now, if you were not receiving any value, then you will write it like this. If you are only sending the values, if you are receiving, you have to write it like this. If you are sending only, then you have. If you are sending and receiving, then you have to write it like this. Okay. Then you have an array for sending values, and you have an array for receiving values. Now, for sending values, you have to send at least 2. So even if you are sending one value, you have to write 2. This is a problem. Maybe we'll fix that later on. But for now, we have this limitation that you can only send a minimum of 2 values. After 2, you can send 3, 4, you write as many as you want. But if you're sending one value, you have to write 2. And here we are also initializing a counter x, so that we are sending the value of this x to our Python code. So we can go and check it out there. Then we are saying that serial data.begin 9600, and this 9600 is the baud rate that should match here 9600. You can change that in both instances. And then we are saying that our digital pin mode 13 is output. So 13 is by default, it's basically an LED over here, and we are using the built-in LED. That's why we are writing that pin mode is output here. We will get the value from the Python 0 or 1, and based on that we will turn on this light or turn off this light. So here we are receiving. So we are receiving the value. We are simply writing serial data.get. We receive the value, and we take the first value of that and we give it to digital write, because it will be either 0 or 1, so we can directly send it. And to send the value, we simply have to put it in our array. So send value 0 is x, and then we write serial data.send, and we send in the complete array. So whatever we are sending or receiving, we are doing it in a list or an array. So make sure you do it in the correct way. So here what I will do is I will upload to this, and what we have to do is we have to select, so Arduino Uno at COM port 11. Now if for some reason you have another Arduino, or it's not detecting, or whatever the case is, then you can write the port number here. And how you write it is like this, COM 11. So this will pretty much do the same thing for us. So whether we write COM 11 or we don't give anything, is in this instance it will do it, because it's an original Arduino and it will work fine. So what we can do now is we can simply right click and run this, and it will try to connect, attempt 1 of 5 to connect Arduino connected on COM 11, and then it started receiving the values. So as you can see, it keeps receiving, and let's see if it goes to actual 100. Yes. So from 0 to 99, and it's getting each and every single value. As you can see, it is getting that, and whether we are able to send or not, we need to check that too. So we need to check on our Arduino. So here you can see the light blinks, turns on, turns off, turns on, turns off. This means that our data is being sent, and we are able to detect or we are able to send our data as well. So you can send as much data as you want. You can send a list of arrays and all this, and it will still work. So this is basically how you can use your serial module. So the last module we are going to look at is our plot module. Now this is very, very useful because there's no functionality in OpenCV to actually live plot our values. So in many instances, this value can be very useful to see it in a graph or a plot to see how exactly the value is changing. And you can do this with matplotlib, but it is not very easy to do. So that's why we have created this plot module. So all you have to do is you have to write CVZone.plot module and import the live plot. And this is the face detection module. We are importing this as well because we want to demo face detection center point. We will move our face, and based on that center, we are going to plot that center value. And we will do that later on. But first, we are going to go ahead and we are going to plot a sine wave. That's it. So this will be our sine plot. All you have to do is you have to create an object from this class, live plot. Here you have the option of the width of the plot itself, and then the limit of the y-axis. So it is from -100 to 100 in this instance, and the interval in seconds, it's 0.01 seconds. So that's the basic idea. And once you have that, we are declaring a variable x sine because we want to change the value of the sine. And all of this is basically for the second part, which is face detector. We will look at that later on. And this is for face detector as well. Let's push it up here. And we will comment it. And this part here is only for sine. So there you go. So this 3 lines is for sine. And this is for sine. And this will display us. So we are running the webcam as well. If you want, you can remove that too. So here we are putting the sine function, and we are multiplying it by 100 so that we don't get decimal places. Instead, we get these values. So what we need to do is we need to run this. It was running the previous module. So there you go. This is our webcam, and this is our plot. And as you can see, it is plotting live. So 1200 was this width, and as you can see here, it's -100, and here it's 100, the minimum and the maximum. And you can also give a character here defining which value you are plotting. So you can give only one character, by the way, here, and it will display the values here as well. So this is basically for our sine, and this character you can define over here. So by default, the value is y. So you can write here character is empty if you want it empty, or you can or we can write S for sine wave. And for our x plot, we are going to write y because this will be our y value. Or let's plot x. Yeah, let's put the x value. Okay, so we will open our detector. This is a face detector with a confidence of 0.85, and we will open all of this face detection parts. And we will also open the xplot.update. By the way, this is the only line you have to write. Whatever you named your object, xplot or sine plot, and you only have to write .update, and you give in the value. That's it. Whatever value you want to update, and it will return you the image of that plot. So that's the basic idea. So here we have image plot, and then we are going to display this as well. And do we have any errors? What is this? Okay, these are comments. Okay, so that's the idea. And now what we are doing is we are looping through the bounding boxes, and we are getting the value of the x. So value is basically x value. From the center, we have x and y value. So we are getting the x value, and we are putting in our plot. So let's run both of them. It will run the sine plot as well, and it will run our x plot as well. So let's see how that goes. So here you can see it is detecting my face, and then we have our sine plot, and then we have our x plot. So here, for example, if I move left, right, by the way, we need to change the x and y values. Yeah, it's already here. It's 0 and 500, so that's fine. So and whenever the there's a mistake here, 0.01. So whenever it is not able to detect the face, it will give the value of 0, because here we are defining that the value is actually 0. So here is our image, and here is our image plot, and here is our sign. So if I go up, oh, not up, left and right, so you can see it moves. So there you go. And here we don't have negative values, it's from 0 to 500. And you can see when the detection is lost, then it gives you these random values. Otherwise, you can see it works fine. And the same way you can do it for Y. So you can do it for Y-axis, and you can also stack these together. That's the best part. So you can write here that image stack equals CVZone, and you can see they are all different sizes, but you can still stack them. CVZone.stack images, and you give in your image and then image plot. And we need 2 columns, and the scale is 1. So it will squeeze the image so that it is of the same size, and it will display us. So oh, actually we need to output that as well. So we'll copy that, we'll write here image stack, and we will write here image stack. So let's run that. So now it's a little bit squeezed, but you are able to see the values together, and you can see it works fine. So that's the beauty of the stack function and all these different functions that we have created within our CVZone library, that they integrate with each other very easily, and it makes so much easier for us to create these projects and to have some exciting results. So this is it for our video. As you have seen, we have covered a lot of different modules, and we have covered a lot of different functions, methods within those classes, and all of these are very useful, and they help you create new functions and create new projects very quickly. Now, if you have something very particular you want to add, let us know. Send us an email that we want to add this functionality to this CVZone platform, and we are going to go ahead and do that, and we will keep updating this so that it is the latest version. So this is it for today's video. If you liked it, give it a thumbs up. If you loved it, share it with your friends, and I will see you in the next one.